Hey everyone, I wanted to go through a few examples of how to write loops. And these are examples that I went through in one of the lectures, but I wanted you to have a standalone version so that you can go back to it and reference it when you need to. So the first loop I want to write is computing a sum using a loop. I want to point out that MATLAB does have a built-in function that does the same thing, though it doesn't use a loop. So if I wanted to sum from 1 to 10, I could use this function sum. Now, we don't want to use this because we want to practice our skills using loops, but this is a good way for us to check that we're computing the correct thing. So we know that once we write our loop for this, for the sum from 1 to 10, we should get 55. So I just want to point that out. So we're not going to use the sum function, we're going to just use loops. Let's start off by using a for loop. And I'll show you how to convert it to a while loop as well. So we want to compute this sum. Let me write down what's going to happen at each step of the loop. So the sum we're trying to compute, let me get to my whiteboard here. The sum we're trying to compute looks like 1 plus 2 plus 3 plus 4 all the way to 10. We want to use a loop to do this. So in the first step of our loop, we're going to have s equals 1. In the second step, we're going to have s equals 1 plus 2. In the third step, s equals 1 plus 2 plus 3. And the fourth step, s equals 1 plus 2 plus 3 plus 4. And I'll write down the 9th step and the 10th step. So for the 9th step, we want to sum from 1 to 9. And in the 10th step, we want to sum from 1 to 10. And that's our last step of our loop iteration. 9, 10. Okay. This is what we're trying to capture in our loop. And one thing to try to identify is what is changing at each step of the loop. That's going to give you a sense of what your loop index should be or where it should show up inside of your loop. Now, there's a few things I want to point out here. Notice that in the second step here, 1 shows up, and that's actually the one that we had in our previous step. In the third step, 1 plus 2 shows up, which is the value of s in the second step. In the fourth step, 1 plus 2 plus 3 shows up, which is the value of s in the third step. So we're going to have s is going to show up in our loop, in our computation. And then I just want to also point out 1 plus 2 plus 3 all the way to 9 was the value of s in the previous step. So in our 10th step, we also have that showing up. So you can see that we're going to be using s inside of our loop. The idea is that we're going to be overwriting s, actually. And the quantity that's changing at each step, that's kind of tracking our loop, are these last elements. Those are the things that are being added on at the end. And so this is when j equals 1, this is when j equals 2, j equals 3. So notice that this is actually our value for j. Here, this is j equals 4. Actually, let's use k for our loop index. So I'm going to say this is when k equals 1, k equals 2. It doesn't really matter what letter you choose for your loop index, as long as you use it in your loop and you don't try to use a different letter once you get started. So we'll use k for this example. All right, so we're going to go ahead and write this loop. We could try to write something like for k equals 1 to 10, s equals s plus k. So again, this is, we're overriding s at each step. So we're not storing this as a vector. This is just being overwritten. And we want the previous value of s, that's all these blue circled pieces here, plus k, which is our loop index, the thing that is getting updated at each step. Now, if I try to run this, MATLAB is going to get angry with me. It says unrecognized variable s. And that's because I'm trying to do this computation at the very first step when k equals 1, and I don't have anything specified for what s is to start. So we're going to initialize s to be 0. Now this makes sense because it'll say 0 plus 1. Okay, so now when I run this, I get 55 at the end. So I didn't suppress the output, that way you could see what was happening. So in the first step we had, let me get a marker here. In the first step we had s starts out as 0. This is 0 plus 1, because k takes on the value of 1 in the first step. So that's why we get a 1 here. Now s has been overwritten. S now holds the value 2. So when the loop starts, now holds the value 1. So when the loop starts over, k equals 2. That's what we have here. So when k equals 2 and s equals 1, this is computing 1 plus 2. And I'm storing that now in the value for s. So s is now 3. That's what we see here. Now we're going to go back and update the loop again. So k takes on the value of 3. So we're on this step. Now this is s equals its previous value, 3, plus k, which is 3 as well. So that's where we get the 6. Then we'll have, when k equals 4, s is going to be 6 at that point. So this will be 10. And we keep going all the way to 10. So if I scroll down here, you can see we have 10 here, 15, and then we get the 55, which is what we expected to get when we use the built-in function to check our work. And that's it for the sum computation using a loop. Let's also see how we would use a while loop. So using a while loop. So let's say I just copy and pasted my for loop stuff. You know, maybe it's similar. Instead, so I need to point this out. This is incorrect. This is a wrong syntax for a while loop. I should not have a vector or like an k equals a vector. This doesn't really make sense for a while loop. The while loop is asking a question. It's saying, is this condition satisfied? And right now this is not a question, this is a statement. So the question that I want to pose here is k less than or equal to 10? That's my question for the while loop. So right now, so if I clear all of this, if I try to run this, MATLAB's going to get mad at me. It says unrecognized variable k. I'm trying to test a condition here and k doesn't exist yet. So MATLAB's like, this isn't going to work. We just need to initialize k. Let's go to our for loop to see what k starts as. K starts out as 1. So we're going to initialize k to be 1. And it ends at 10. So that's why I have while it's less than or equal to 10. Okay, still not quite correct yet, so I'll show you why. Let's try to run this. And we got an infinite loop. So you can see the numbers are just flying by. So I'm going to Ctrl+S to break out of that. And the reason this is infinite is because I have not updated k inside my loop. K is always 1 right now in this setup. I set k to be 1 and I said while k is less than or equal to 10, do this thing. Well, k is always going to be less than or equal to 10 because it's equal to 1 forever. So this is asking, is 1 less than or equal to 10? Yep, do this thing. Is 1 still less than or equal to 10? Yep, do this thing again. And then it keeps asking, is 1 less than or equal to 10, which is always true. So at some point we need this condition to be false. So we need to update k. And we're going to put k equals k plus 1. Now, when this loop runs, it'll update k to be its previous value plus 1. So when k is 1, we go through, we do this step. Now k gets updated to 2. Now the question is slightly different. Is 2 less than or equal to 10? It is. So we do this step, we update k, now k is equal to 3, and we keep doing this. At some point, k will be bigger than 10. At some point, k will be equal to 11. This condition will then be false, and that way our loop can end. So now, let me try running this again. And I did not suppress the output just so that I could show you what we get. So let me scroll up here. So we start out with s equals 1, and here you see that k got updated to be k plus 1. So its previous value was 1, it got updated to 2. And then we compute s plus k, so this is going to be 1 plus 2 is 3, k gets updated to 3, and we keep going all the way until our very last step where we compute, 1 plus 2 plus 3 plus 4 plus all the way up to plus 9 plus 10, k gets updated to 11. And now this question is 11 less than or equal to 10? The answer is no. So this loop ends at that point. And we want our loops to end at some point. We don't want to write infinite loops. So that's how we would write two different versions of the same computation. So summing the numbers from 1 to 10. I want to I want to kind of modify this example a little bit. Let me get my question here. Let's modify this to be a function. So I already wrote the functions earlier just to make sure that it's all going to work out. So I want to rewrite those functions in this video. So let's get rid of these things. So instead of summing from 1 to 10, we're going to write a function where we can add up any number we want from 1 to that number. So the input is going to be capital N, and we're going to output the sum S all the way up to capital N. So let me open this. So function S is our output, sum fun, N is our input. I'm going to copy and paste one of our computations here and just show you how to modify it. So it's going to be very quick. Right now this loop is computing the sum from 1 to 10. So let me just suppress this output. And all we want to do is change that to go from 1 to n, any n that we input. And then we save that. And that's it. That's our function. So notice that there's a few things here. N is an input, so I never want to overwrite my input. That kind of defeats the purpose of this being a function. If you overwrite this variable inside your function, then this variable is kind of useless as an input. So you don't want to be overwriting it. Another thing is when I'm computing this sum here, notice that capital N does not show up here. And that's because it's playing the role of the number that I want to stop at. It doesn't really have an effect on this computation other than it tells me when to stop. That's not the case for every problem or every loop that you'll ever write. Maybe you'll have n showing up somewhere, but in this case, it's just telling me when to stop the loop. And I still need a loop index k. So let me go back here and call my function. So let's call it for n equals 10 to see if we get the same thing that we got before. And we do. We get that 55, which is, we know that is equal to 1 plus 2 plus 3 plus 4 all the way up to 10. But the beauty of a function is that now I can compute this sum, 1 plus 2 all the way up to n, for any number I want. Let's say like 532. What's the sum from 1 to that number? 141,778. So that's what makes a function great, is that you can now plug in any number you want and it'll do that same computation. We can also check that this is correct. So 1 to 532 using the MATLAB function, we got the same answer. So that just is like a little check for us to make sure that we're computing the right thing and our function is working. But we didn't use this built-in function. So just to highlight that, if I ask you to write a loop, don't use a built-in function like this unless I specifically say you're allowed to. Okay, so the next example I want to do is how to write a loop to compute a cumulative product. So instead of 1 plus 2 plus 3 all the way to 10, we're going to do 1 times 2 times 3 times all the way up to 10. That's going to be very similar to what we did over here. So let me grab another board here. Okay. All right, and we're going to kind of do the same process. We want to compute 1 times 2 times 3 times 4 all the way to 10. So in the first step of our loop, p is going to be 1. In the second step, p is going to be 1 times 2. In the third step, p is going to be 1 times 2 times 3. Fourth step, we're going to get, 1 times 2 times 3 times 4. And then we're going to keep going all the way to the 10th step, where we compute the final product that we wanted, times 3 times 4 times 5, all the way to 10. All right. And the same kind of thing is happening here. So again, MATLAB does have a function that's built in that does this for us, but we're practicing loops right now. So if I wanted to know what I should get out of this function, I would use this built-in prod function. I should get this number here. So 3,628,800. That's the number I should get if I do my loop correctly. So let's try to do that. Let's try to capture that. Now, again, we see that our previous values, so our previous values of p are showing up in each step. So 1 times 2 in the third step, that's the value of p from the second step. 1 times 2 times 3 in the fourth step is p from the third step. And the thing that we're keeping track of here, this loop index that we're going to have, here is when k equals 1, here is when k equals 2, here is when k equals 3, and then when k equals 4, and then down here this is when k equals 10. Oh, you can't actually see that. So this is when k equals 10. There we go. Okay, so it's going to look very similar. K equals 1 to 10, p equals p times k this time. Again, we're not quite finished. MATLAB's going to get mad at me. There it is, mad at me again. Unrecognized function or variable p. So again, we tried to do a computation here, and at the first step, p doesn't have a value. So we need to initialize p. If I try to initialize p to be 0, this is going to be bad, because I'm just going to get 0 every single time, because I'm doing 0 times a number, that's 0. So 0 times another number, that's 0. So we don't want p to start as 0. We want p to start as 1. That way we have 1 times something, and then that number times another number. So we're not actually zeroing everything out. So now if I run this, I get the 3,628,800 that I was expecting, which is the product of 1 times 2 times 3 all the way up to 10. Okay, so that's how we would compute this product with a for loop. So maybe I should title this using a for loop. And now let's convert this to using a while loop. Okay. So let's try to use what we've done. Again, if I change this to a while, this is now wrong. This is incorrect syntax. So I don't want to see anybody doing this syntax. It's wrong. We need a condition here. So we're going to put less than or equal to 10. While k is less than or equal to 10, do this thing. Now k we need to initialize. So we want k to start with the value of 1. So I'll put k equals 1 to start out. And again, we need to update k so that this is false at some point. K equals k plus 1. Oops. And this should compute the same thing that we just saw. So we get that final product, 1 times 2 all the way up to 10, and k is 11 at that point, and so our loop ends. So I'm going to go ahead and clear all of this. So that's how we would write a cumulative product as a sum, either way, as a for loop or a while loop. So the luxury of using a for loop is that the loop index is automatically initialized and updated. So it kind of eliminates these 2 steps here. The bad part, or I guess not a bad part, but you need to know when to stop, when you want to stop your for loop. If that's unclear, if you're not sure when your loop is supposed to stop, or if it's some sort of condition that you're trying to satisfy, you're going to want to use a while loop. Let's write a function that does this. So just like we did with the sum fun, we're going to write a prod fun that computes the product from 1 to n. So function p will be our output, prod fun, our input is going to be n. All right, so this time I'll use the skeleton I'll use is this while loop, since we used the for loop last time. So I'm going to copy and paste this, and again, I want to use this variable, our input variable. This is where I want my loop to end, so that's going to play the role of the 10 that we had before. And I'm going to suppress the output here because I don't want it to print everything I'm doing. So I'm going to save this. Okay. And this is all we had to do. We just had to update that. So I'm going to go over here and call my function prod fun 10 again, just to see if it works. It does. We got that same value. But let's call it for a different number. Let's say we want to know the product from 1 to 15. What does that look like? Whoops. Copy and paste. Okay, so much bigger. We can also check that our function is correct by using the built-in function. We want to make sure this, when we inputted 15, matches the built-in function MATLAB has, and it does. So our function is doing the right thing. Okay, at the risk of making this video longer, I'll stop there. Hopefully these two examples were helpful, and let me know if you have any questions.